Hi, so in this video we are going to construct the rotations and we start with the right rotation. So I'm going to create a private void method for the right rotation. Right rotate, for example, it's going to get a node basically. It's very important that sometimes this node is going to be the parent of the node we have inserted, and sometimes this node is the grandparent of the node we have inserted. Okay, I'm going to print out that rotating to the right plus the node. Okay. Then basically it's going to be very similar to what we have seen in the AVL3 implementation, but it's very important that we have to handle the parent references and the parent nodes as well. So it's not enough to just make these reference updates. We have to tell the given nodes that what's going to be the parent after the rotation. So we get the node.temp left node. Basically it is the same as we have seen for the AVL3. It is the node.get left child. Then we set the node.set left child to be equal to the temporary left node dot get right child. Okay. Then we check whether if the node dot get left child is not equal to a null, then basically the node dot get left child, we set the parent, so get left child that set parent is equal to the node. Okay, so that's why it's going to be a bit more complicated because we have to handle the parents as well. Okay, temp left node dot set parent is going to be the node dot get parent. And then we have to check that if the temporary left node dot get parent is equal to a null, it means that basically it's going to be the root node. So the root node is going to be the temporary left node. Else, if we have to check whether this given node is equal to the node dot get parent dot get left child. What does it mean? We check whether this node is equal to the node get parent get left child. So basically we check whether this node is a left child or not. If it is a left child, then we set the node get parent dot set left child to be equal to the temporary left node. And else we know for certain that the node is a right child of its parent, so we say that the node get parent dot set right child to be the temporary left node. Okay, anyways we are going to have this temporary left node and set the right child to be equal to the node. Okay, and then we set the node dot set parent to be equal to the temporary left node. So basically it is a bit more complicated as we have seen in the AVL section because we have to handle the parents as well. Okay, so that's all about the right rotation. What about the left rotation? Basically it's going to be approximately the same, so I'm going to copy and paste it, although we have to be careful. So it's going to be the rotate left, so rotate to the left. We are going to create a temporary right node and we get the right child. Okay, so instead of left we get the right, and then we set the right child, so set right child, and we get the temporary right node dot get left child. Okay, if the nodes get right child is not equal to null, so basically we have to change every right to left and left to right, but whatever, we just get the right child and set the parent to be equal to the node. Then we set the parent for this temporary right node to the node.getParent. If the temporary right node, of course, get parent is equal to a null, then the root is going to be equal to this temporary right node. Else if the node is equal to the node get parent get left child, then we set the node get parent set left child to be equal to this temporary right node. Else the nodes.get parents.set right child is equal to the temporary right node. Then the temporary right node set left child, okay, we have to swap it, going to be equal to the node, and the nodes.set parent is equal to the temporary right node. Okay, this is how we make the rotations. In the next video, finally, we are able to start implementing this fixed violation method. Thanks for watching.